there's something else that's showing up in Murchison. Something quite, well, partly expected and partly unexpected. I have a picture of Allende here because it photographs nicer than slices of Murchison. You can see some chondrules, and you can see something else, these sort of irregular white shapes here. You might wonder if those are metallic iron. No, they're not. Another stony material. There are a variety of chemical compounds in there, in those, but they're rich in calcium and in aluminum. They're calcium aluminum bits, and we've long considered those are probably pre-solar in age. Now, what does that mean? I'll examine what those mean a little bit more in the next slide, because the CIAs occur in many different types of chondrite meteorites, not in all varieties, but in some of them it does, not just in the carbonaceous ones. They do not exist in stone, in the achondrites, and they certainly don't occur in any of the iron meteorites, just in some of the chondrite types. Well, here's a slice of Murchison. You can see that black look to it, and that's because of the sort of tarry material. Not a huge amount of it, only 2 to 4% of the meteorite is this kind of material mixed in with everything. But there are the chondrules. There are some CIAs not apparent in this particular slice. And what you cannot see, but you can get when you dissolve this thing and look for the tiniest fragments of stuff there that you can find, and you'll find some little fragments that are only about 1/1000th of a millimeter in diameter, rounded to angular. And these are made of a chemical compound called silicon carbide. We find a little bit of silicon carbide grown in iron meteorites, but it has a totally different form and a totally different relationship. Here they're just little isolated fragments. Silicon carbide is a hard material, does not occur naturally on Earth, but we manufacture it. Because it's so hard, we use silicon carbide as an abrasive, and some types of sandpaper you can buy use not just regular sand grains, some use silicon carbide. But here it is in Murchison. Now, the people that did this work found a way to date the time when these fragments crystallized. And that time was about 7 billion years ago. Now that is astounding because our solar system became our solar system at a time that began about 5 billion years ago, when the remains of a supernova, or perhaps several supernova, giant stars that exploded, and stars like that will always explode. Astronomers are able to observe about 50 of these a year that they see, some in our galaxy, mostly in other galaxies, just because you get a better sample by looking at other galaxies. But the dust and gaseous vapors produced by that explosion slowly cool with time and find ways to coalesce, partly through the action of gravity. And they coalesce to form objects big enough to be smaller stars, with debris left over that, again, working largely through gravity, become planets, moons, asteroids, comets, and whatnot. Well, that whole action for our solar system just began about 5 billion years ago, and by 4.57 billion, our sun was a glowing sun. It had gotten big enough and compacted enough that atomic fusion was occurring, production of hydrogen, atoms squeezing together to form helium, as it still does today. Surrounding it was a big disk of dust, coalescing dust, and a few 100 million years later, Earth and the other rocky planets were, I was about to say much like they are today, but I'll just say much the same size as they are today, by 4.54 billion years ago, which we consider to be the age of the Earth. Now, Earth was starting to form, and there was something here well before then, but it was still in its growth stages. So here, 2 to 3 billion years older than any of this, these little fragments of silicon carbide, so those could only have formed in that supernova as a result of that supernova. And those fragments of that supernova then have remained unchanged, whereas everything else has managed to change somewhat by other chemical action. And there the little tiny bits of dust occur in Murchison meteorite. And this is why it costs so much to buy a piece of Murchison if you can ever even find a piece for sale.